In this video, we're going to learn how to easily diagnose ignition faults in vehicles fitted with coil pack ignition systems. When looking for the cause of engine misfires or a no-start situation, always begin your diagnosis by testing battery voltage. If you have ruled out mechanical and fuel faults, the ignition system can now be diagnosed. Fault codes relating to engine misfires, such as DTC P0300 to P0312, may be caused by faults within the ignition system. We need to check the availability of high tension voltage at the spark plugs. This could be done by removing the coil pack and installing a spark testing device. Always disable the fuel system, as we do not want to damage any other engine components with unburnt fuel in the system. Make sure you check each coil output and do not adjust the tool between tests. We could leave the coil in place and use a designated coil testing probe. This is a much faster and easier way. Or, if you have access to an oscilloscope, such as the Pico, you could use the coil on plug probe. If these checks uncover weak or no spark at any of the secondary outputs, the primary side must be checked. If the spark at the coil is acceptable, remove and inspect the spark plugs for serviceability. Always keep the plugs in the correct order to help ascertain which cylinder is at fault. This is a typical schematic of a coil pack equipped vehicle. An ignition source, ground and primary trigger is supplied to the coil pack assembly. Confirm that ignition voltage is available to the coil pack by connecting 1 metre lead to battery negative and back probing the ignition supply terminal with the other. Incorrect or no voltage here would indicate a short to ground, an open or excess resistance in the supply circuit. This may be a reason for no secondary output. Remove and inspect the supply fuse. An open fuse indicates excess current draw in the circuit. This may be caused by a short to ground. Disconnect the ignition coil and connect a multimeter set on volts across the fuse terminals. Turn the ignition on. If the meter displays 0 volts here, then the short is in the coil pack assembly. Any other voltage reading indicates a short to ground in the circuit. Disconnect the next section of harness to help isolate the short. If the meter now displays 0 volts, then the short is in the section of harness you have just disconnected. If the meter still displays voltage, then the short is between the fuse box and the last disconnected connector. If when back probing the ignition coil supply circuit, no voltage is seen and the fuse is okay, then an open circuit would be the most likely cause. Remove the fuse and switch the ignition on. Using the multimeter set on volts, test for battery voltage at the fuse supply terminal with one lead and connect the other to battery negative. If the meter displays 0 here, then further testing of the relay circuit will be required. If voltage was displayed, check for fuse terminal tension and corrosion. If this is okay, reinstall the fuse and move the meter lead to the first inline connector. If no voltage is displayed here, then the open is in the first section of harness. If voltage was found, continue testing the harness. Move the meter lead to the opposite side of the connector and retest. No voltage here would indicate an open in the connector. If voltage was displayed on both sides of the connector, move the meter lead to the next harness connector in the circuit and repeat the process to isolate the open. A voltage drop of any significance in the coil supply circuit may cause a misfire or a no-start complaint. This voltage drop may be caused by excess resistance in the supply circuit. With the ignition on, remove the fuse and confirm battery voltage is available on the supply terminal by connecting the meter leads between this terminal and battery negative. If significantly less than battery voltage is displayed here, perform diagnosis of the relay circuit. If correct voltage was displayed, check for corrosion and terminal tension. If this is okay, then reinstall the fuse and move the meter lead to the next connector in line and retest. If the displayed voltage is still low, then the excess resistance is between the fuse and this connector. If the correct voltage is displayed, move the meter lead to the other side of the connector while watching the meter. If incorrect voltage is displayed, the excess resistance is in the connector. If the correct voltage is seen, repeat this process for the rest of the circuit to help isolate any excess resistance. The low reference circuit for the ignition system plays a key role in the delivery of high tension voltage to the spark plugs. A short to voltage, open or excess resistance here will cause misfires or no spark at the coil. With the meter set on volts and one lead connected to battery positive, back probe the low reference circuit at the coil pack. Battery voltage should be displayed. A meter reading of 0 or significantly less than ignition voltage may indicate an open, short to voltage or excess resistance. To rule out a short to voltage, move one meter lead to battery negative while watching the screen. Any reading here confirms a short to voltage in the circuit. 0 volts indicates an open or excess resistance. With the meter connected between battery positive and back probed at the low reference terminal, unplug the ignition coil. If the meter now displays battery voltage, the short to voltage is in the coil pack. If the meter still displays 0 volts, turn the ignition off and disconnect the ECM. Switch the meter to ohms and perform a continuity check between the low reference terminal in the coil pack harness connector and all other terminals in the ECM connector. If this is okay, then the short is in the ECM. With the meter connected between the low reference terminal at the coil pack and battery positive, and a short to voltage ruled out, a meter display of 0 would indicate an open in the ground circuit. Move one meter lead to the ECM low reference terminal and monitor the display. If the meter now reads battery voltage, the open is in the harness. If battery voltage was still not evident, disconnect the ECM and check the harness connector ground terminal for corrosion and terminal tension. Check the ECM low reference pin for any evidence of corrosion. If no fault can be found, then the ECM must have an internal open circuit. To check for excess resistance in the low reference circuit, disconnect the coil pack and attach the meter between battery positive and the low reference terminal in the harness connector. Be sure to confirm the tension of this terminal is acceptable. Significantly less than battery voltage would indicate excess resistance in the circuit. Move one meter lead to the next connector in line while monitoring the display. If the meter now reads battery voltage, then the excess resistance is between the two connectors. If a low voltage reading is still evident, then disconnect the ECM and check the low reference terminal in the harness connector for corrosion and terminal tension. Be sure to check the ECM low reference pin as well. If no fault can be found in the harness or connectors, then the excess resistance will be internal to the ECM. The schematic for this vehicle shows a pull-down driver in the control module for each primary winding within the coil pack. The best way to test this is with an oscilloscope. Back probe the primary trigger inputs with each channel of the scope. Crank or run the engine and watch the trace. An acceptable single trace looks like this. If there is a problem in any of the driver circuits, you will not see the ground trigger on that trace. A misfiring engine with an open or short to voltage in a driver circuit will look like this. We know that this is an open circuit or short to voltage because the cylinder with the misfire shows ignition voltage. To differentiate between the two, switch the engine off and disconnect the coil pack. Turn the ignition on while watching the trace. If the scope still shows voltage on the trace, then there is a short to voltage in that circuit. Turn the ignition off and disconnect the ECM. Turn the ignition on and watch the scope. If voltage is still displayed on the trace, then the short is in the harness or a circuit from the ECM. If when disconnecting the coil pack, the trace dropped to 0, then an open is the fault. Reconnect the coil pack harness connector and move the scope lead to the ECM and back probe the same trigger circuit here. Start or crank the engine and watch the trace. If the correct pattern is displayed, the open is in the harness between the two connectors. If no pattern is displayed, turn the ignition off and disconnect the ECM connector. Inspect the suspect terminal for tension and corrosion. If this is okay, the only possible fault is the ECM. A short to ground on the driver circuit looks like this. The trace is held at 0 volts with the engine running. Turn the ignition off, disconnect the ECM and the ignition coil. Move the scope ground lead to battery positive while watching the trace. If the trace displays battery voltage, then the short to ground is in the harness. If the scope trace stays at 0, the short is in the ECM or a circuit from the ECM. Perform a continuity check between this circuit and all other ECM circuits to eliminate a short in the harness. If there is no continuity between the circuits, then the short will be in the ECM. If all circuits test OK and the ECM is delivering a correct trigger, then the coil pack can be replaced with confidence. Always replace the spark plugs as part of the repair. The main killer of coil packs is extended peak voltage operation. This is generally caused by an excessive spark plug electrode gap, as you would find in plugs that have passed their service life. Thanks for watching.